Next paper is identity-based secure end-to-end quantum safe MQTT communication using Ring-LWE. Author is Gunasekaran, Raja and others.
Sudhakar, that is the second author listed in the PPT. I am from Anna University MIT campus, assistant professor in the Department of Computer Technology. So I am going to present my paper. So my topic is identity-based secure end-to-end quantum safe MQTT communication using ring learning with error problem. So outline now my presentation is problem statement, objectives, some related works, proposed system, architecture and algorithm, then result analysis and conclusion and some of the references. So all we know for the industrial IoT environment or any lightweight device environments or resource constrained environments, so we have some specially designed protocols like MQTT, that is message queuing telemetry transport protocol. Okay, so this protocol, so in IoT environment or industrial IoT environment, there are many machines, many IoT devices can communicate with many-to-many communications. For many-to-many communications, so the MQTT protocol is designed. So from this protocol follows the publish subscriber model. So the machine-to-machine communications can be done in many-to-many communication using this model. But in this model, there is a in-between device or a gateway called broker. So broker is the sweet part for the attackers. So the communication is communication between the publishers and subscribers between the brokers. So there is a security issues. So there are solutions for these security problems, particularly the TLS-based digital certificate-based solutions are there. But in order to avoid that complexity and scalability problem from these certificates, we are proposing the identity-based encryption based on the ring learning with error problems. So this is our problem statement. So objective, therefore, we have to design and integrate a Ring-LWE based identity-based encryption scheme into the MQTT protocol to enable secure key exchange and post-quantum end-to-end encryption without relying on pre-shared secrets. I think I skip these related works. Directly coming to the architecture diagram of our proposed MQTT, that is modified MQTT protocol. So in this architecture, we have 5 entities, mainly publishers, broker, key store, the subscriber, and particularly the trusted authority KGC, private key generation or key generation center. We can say PKG or key generation center. Okay, so initially the PKG, that is private key generator, set up some system parameters based on the given security parameter. The system parameters contains the master secret key and master public key based on the quotient ring, and then it generates the trapdoor ring for generating the private key for each user. User may be, for example, key store or subscriber. So this is the initial setup. The KGC prepares the parameters for the whole system. Master secret key, it is a matrix or polynomials from the quotient ring. And then some trapdoor, that is also some hidden structure that is allowing us to generate secret keys for each user. Okay, so that is the initial setup. Then publisher gives the content based on the topics. The subscriber receives the topics contents based on the topics. Okay, so this has to be communicated confidentially. So therefore, the end-to-end encryption is necessary. But in the architecture, publish subscriber architecture, we have the broker entity. So where we have some security vulnerabilities. Okay, so therefore we need to adopt the very good security mechanisms. So instead of digital certificates, we are allowing identity based. So in this diagram, the publishers first generates the symmetry key. Okay, so that symmetry key. Second point, that the publisher generates the topic key. That is, the topic key is used to encrypt the topic. So based on the topic, that means that content. Okay, then the topic key is used to encrypt the given message. Then the symmetry key is encrypted by, so initially before encrypting the symmetry key, one more point I want to tell you, that the key store and subscribers initially register to the PKG, that is private key generator. They give their identity to the PKG, then get the private key, because their identity is used as their public key. So this is also a public key based crypto system, but without digital certificates. Here, the user's identity is used as a public key. So for example, user's email ID, even fingerprint, that can be converted into a vector that is mapped to some ring element. So in this way, some sort of authentication is also needed to give that public identity, that is identity of the user, to the PKG. Then PKG uses is master secret key with the identity of the user. It generates the secret key for each user. The similar procedure is followed for both key store and subscribers. So in this way, the key store and subscriber sends their identity to the PKG. Then they get the secret key or private key for them. Okay, so after the symmetry key is generated by the publisher, it is encrypted by using this Ring-LWE method, that is post quantum cryptography method. That is sent to the key store. So the key store receives the encrypted symmetry key, and also the publisher generates the topic key, and it is encrypted by that symmetry key. That message is encrypted by topic key. So that encrypted topic or message is sent to the broker, that is forwarded to the subscriber in the requisition. Okay, but that topic is not decrypted in the broker side. That is sent to subscriber. That is sent to key store, and the content is directly sent to the subscriber without sending the key store. So if the subscriber needs to receive any topic of interest, they have to give the request to the key store. Then the key store sends the symmetry key, that is symmetry key encrypted by the subscriber identity, that is the public key, because that is authorized by this KGC initially. Then after receiving that public key, that symmetry key, the subscriber decrypts that symmetry key using again Ring-LWE based decryption. After that, we get the topic key. Okay, so the topic key, that symmetry key, that symmetry key, using that symmetry key, the topic key is decrypted. Once the topic key is decrypted, the final message is decrypted. So in this way, the publisher gives the content or topic, the subscriber receives the topic or content with end-to-end security. So this is our full explanation of our architecture. So the same thing is given as equations. I skipped all those things. Even with the same points are given in the algorithm. Maybe I give very quick points. So the publisher side, we generate the symmetry key, topic key. The symmetry key is encrypted with this the hide that is public key of key store, and the topic key is encrypted by the symmetry key, and the message is encrypted by the topic key. And the key store, it decrypts the symmetry key, and while sending the same symmetry key to the subscriber, again it is re-encrypted by the subscriber's identity, that is a public key. Then in the subscriber side, it requests the message, then it receives the encrypted symmetry key, that is decrypted by the RLWE based decryption. Then we get the topic key. The topic key is used to decrypt the message. So that is what given the algorithm also, the same process. So some experimental results. The results are very that is simply the implementation of the cryptographic operations based on the previous existing system. Existing system used bilinear pairing for identity based, but here we have used identity based encryption based on the ring learning with problem post quantum cryptography algorithms. So based on the different message sizes, so our algorithm has less execution time, encryption time, and decryption time comparatively. But our implementation is normal laptop only. Our normal laptop only. That is even with very less configuration, 8 GB RAM and 64-bit operating system and 2 gigahertz machine only. Then again, the set of time comparison. So conclusion, for end-to-end encryption between the publisher and subscriber, that is in order to get the many-to-many communication for the machine-to-machines, we have MQTT kind of lightweight protocols, but this follows the publish-subscriber model. That model has the broker entity in between. That entity is vulnerable. So in order to give end-to-end security, various mechanisms we have to adopt. Thank you. Some of the references. Any questions, please?
Hello. Again,
Sir?
very good work.
Yes, sir.
Go ahead.
They say, for example, for Kyber, it is 3329. For dilithium, some very big value. So what is some considerations for choosing that price? That's what I'm asking.
It takes us actually given different values. We have taken 240.
Okay. Okay. I can ask the question?
Yes, sir.
Okay. See, we understand MQTT is a protocol that's being used specifically for IoT applications because of a certain reason. Right?
Yes, sir. Yes, sir.
It can also be used somewhere else, but most of the IoT cases we have been using MQTT. And when we are using MQTT, we typically use MQTT protocol especially when you send the data from your device to cloud or cloud to device, or when you store the data in either the device or the cloud, right? So now your new protocol, which you call MQTT something, is going to follow PubSub model, right? And PubSub model is typically used to avoid synchronous challenges, in the sense, a client can come and ask, they don't have to wait for the response. They can just subscribe to this particular topic and go. So whenever the data is going to be available, it can get the data. That is a general PubSub. So if you're saying that you're going to use MQTT for IoT based application, and you also call it as post-quantum cryptography safe, two questions. One is, in case of device provisioning, we typically go for this PKI. This is when we actually think of private key, public key, and we have those certificates stored in the devices. Or by default, we burn the certificates in the devices. So that's a one-time activity we do. But if you are following a PubSub model, then it becomes a question of, waiting for somebody's response in order to get those certificates. That is the first question. And the second is the standard question that I asked earlier. How are you calling it as PQC safe?
So second question, what is it, sir?
Second one is, how are you calling it as post-quantum crypto safe? Thank you.
Sir, first question, because it is a PubSub, that is a published subscriber model. So it is mainly designed for this many-to-many, machine-to-machine communications. So that's why we have to avoid suppose the number of machines, many-to-many machines, many-to-many communications, for particularly machine-to-machine, many-to-many communications. So in order to avoid the complexity and scalability of these digital certificates, so we are adopting this identity-based, sir. Some literatures also gave this, but some sort of authentication still required, sir. The second question, because but it is proposal only, sir. In future, suppose the devices are capable of executing this post-quantum cryptography operations, then it may be well suited.
So currently it's not PQC safe?
Yes, sir. Yes, sir. Yes, sir. Because low power, because we tested in laptop only, not for any IoT devices.
Okay.
Yes,
Thank you.
thank you, sir. Thank you very much for.